Did you guys attempt the quiz that I sent you? Let's just quickly discuss that actually. Mm, I hope this is it. Yeah, this is it. Was it this one? Yeah, I think so. This one. So, I got, I think, 30 responses, maybe. Yeah, 28 responses. And I was expecting you guys to score at least 23 points on an average. But looks like it's around 19 and 20. So 19 is the median and 20 is the average. There are three people, one of which is me, myself, who scored 30 or 29. And in terms of questions which were wrong, I think I can see that. Okay, let's just go to individual question and see. Uh, I think this a lot of you guys got right. Okay, 12 out of 28 people got this wrong. In interpreted languages, whole code is checked for the syntax errors first, compiled, and then put to run true or false. So if you remember, I told you that there are two kinds of languages. One is compiled, one is interpreted. So in interpreted, what happens is you run the code will run line by line, and there is no check of syntax errors or whatever kind of errors that get checked before starting running the code, right? So apart from that, you have compiled languages in which you have the entire code will be compiled into a separate exe file, and then it will be put on run. And at the time of compilation, everything related to the code will be checked. So things like syntax errors and some obvious calculations like 1 divided by 0, which will obviously result in some kind of error. Those kind of things are generally taken care of at the start of the code. So Python is an interpreted language where each line of code is run one by one, and there is no syntax error which gets checked before running the code, right? This everyone got right. Which of the following packages modules are used for data analysis? I think this was listed at the top of the first module. So all of these are used for data analysis. Numpy, you've already seen. We have matrix operations in Numpy. With scikit-learn, you do machine learning. So again, it's a part of data analysis. TensorFlow is a very useful library which Google has created. It has functions which can do much more than what scikit-learn can do on its own. And TensorFlow is also used for deep learning and AI kinds of projects. Then you have Matplotlib. It is used to create visualizations in Python. So again, it's a part of data analysis, right? So all of these were the correct answers, and I think TensorFlow was something which not a lot of people filled it up, right? Uh, Most of the people got this also right. I think I did not maybe say it out loud, but repl.it is a platform online wherein you can run Python online instead of downloading it on your system. People got this also right. Choose all that is correct. I think I'll just skip it. It was really easy. This is mostly correct. Okay, in terms of mutable and immutable objects, I'll just repeat myself. So, mutable are the objects which you can like edit after creating them. So, something like a list. You create a list 1 comma 2 comma 3 comma 4, and then you can change the individual elements within the list, right? So list is an example of mutable object wherein you can edit the specific values inside the object. Then there are immutable objects on the other side, which is basically things like integers or strings, let's say. So strings, in the strings, let's say you create a string uh, python. In that case, you cannot edit the individual characters within this string. So string is an example of immutable object. So I think a lot of people got these questions wrong. uh, okay this Okay. Yeah. So this was a question wherein you were asked that how do you copy a list without so that it creates a new object, right? So when you are writing a equals to 6 and b equals to a, in that case, b is not a new object which is created. B is still pointing to a, right? So how do you ensure that whenever b is created, it is created in a new location, right? So for that, you have two options. One is you either use the copy module, or you write something like this, right? If you know how this works, you will understand. So basically you are just writing that, you're not specifying how, where are you starting, where are you ending. So it's just one colon. It just says copy everything. How do you write comments? I think most of you, okay, not most of you got it right. That is unfortunate. So there are two kinds of comments in Python. You can write one line comment using hashtag, or you can write multiple line comments using triple quotes, right? That's it. This is sorted. This is also kind of sorted. How do you represent null object in Python? So I told you it's none, right? Null and NA are not null objects within Python. So null and NA will be treated as a string, not as an empty object. I'm gonna skip this. This is again tuples. Okay, sets may, a lot of you got these things wrong. This is about dictionaries. I think you guys should like go through these things again. So just in case you are giving an interview, this is one of the most common questions that may get asked, like what are mutable objects or immutable objects? How are lists different from tuples or sets, right? So just ensure that you understand why each of these different objects need to be separate, right? So you have sets, you have lists, you have tuples, you have dictionaries. So each of these have very different usefulness whenever you're using them within in your codes, right? So you have to understand which of them are ordered, which of them are not ordered, which of them are mutable, which of them are not mutable, which of them allow duplicates, how exactly do you create them, like you use square brackets or parentheses or curly brackets, right? So those things are important. Cannot see your screen. Are you sharing something? I am sharing. Are you guys able to see my screen? That's unfortunate. I've been talking since a long time. Nishit, can you see my screen? I can see now. Rejoin. Oh, okay. Awesome. Yeah. So this everyone got right. I'm gonna skip this one. What are the ways to import a function in Python? Right. So you have multiple ways. All of the above was the right answer. Um, Choose the correct statement. So this was regarding parameters and arguments. So parameters are those variables which you are creating while defining a variable, right? So when you're writing def sum a comma b, so a comma b are the parameters of the variable of the function, and then arguments are the actual values that you are passing to the function. So if you are saying a equals to 2, b equals to 3, then 2 and 3 are the arguments, right? A and b are the parameters, 2 and 3 are the arguments. So arguments are the values that you are passing to the function. Parameter are the variables within the function which are taking those values, right? And then most of you were happy, which was a really nice thing, or at least happy but worried. That's a little bit unfortunate, but I think it was okay. So that's really nice to know. Okay, I'm not sure how many people are joining today, but we have 11 people, so let's just get started. It uh, should be fast enough today. Um, okay, so we have to go to Numpy. So quick recap from yesterday. Numpy is a module which does very highly optimized matrix operations. You have multi-dimensional arrays which are supported within NumPy, which you can utilize if you are writing any algorithm from scratch. Luckily for us, all the algorithms that we would want to use will already be written within, let's say, Pandas or scikit-learn, so you don't have to do that. But it is still nice to know how NumPy exactly is created, right? So NumPy has a lot of functions which you can use to create different size of arrays and manipulate them, right? Our main utility from Python as a data analyst comes with Pandas, right? So Pandas is something which you will be using much more extensively as compared to any other module in most of the companies, right? So within Pandas, we talked about different things. I'll just give a quick recap. So first thing is that obviously you import Pandas. So generally it is imported as like this. You write import Pandas as Pd, right? You can create data frames in two ways. One is you provide list of list, wherein each list will be one row of the data, and then you also provide what are the column names, right? So this is one row of the data, then this is second row of the data, and then so on and so forth. and then lastly you have provided column names, right? So if I write it like this, and the function that you use is pd dot data frame, right? And it will create a data frame like this. So you have columns, you have rows, and then you have values within the data frame, right? Another way to create data frames is you write as a dictionary. So when you write as a dictionary, you have to provide the column name, and then the values of that particular key will be the values in the column, right? So if I do it like this, it will again create a data frame for me. Okay, but thing is, you won't have to create data frames from scratch. In most cases, you will have to just import it from a CSV file, right? So CSV files are generally opened in Excel. The same thing you can read in Python using Pandas also. So I have a data set called Iris. If you guys remember from the last time, it has information regarding 3 different species of iris flowers, right? So let's just do this. So first thing that you have to do is you have to change the working directory. So wherever your file is located, let's say iris.csv is located in this particular folder. So I'm just gonna write that particular folder here using import CSOS module. I'll be changing the working directory. Once you've done that, then you can import the dataset using pd.readcsv, right? Uh, so this is how it looks like. This is just the top 5 rows. So top 5 rows you can get by writing data frame variable dot head, right? And within head you can specify any number of rows that you want to see. But if you don't specify anything, you'll just get 5 rows. So you have gotten top 5 rows here, right? There are multiple other functions which are supported by read CSV, which you can explore on your own later on. Uh, Apart from using the default which I have used above, there might be some cases wherein you would want to use delimiter or separator or maybe header, uh, data type, right? So these are the different things that you might have to use, but in most cases you'll just have to write this particular thing. You just write pd.read CSV, and within that you just write the uh, name of the file, right? Now once you have imported the data set, the CSV file into Pandas, there are few things that you have to absolutely do, so to make sure that you're not making very silly mistakes, right? So first thing is you obviously check the shape of the data, right? So let's say if you are downloading your data using SQL from some server, you would know how many rows or how many columns you have got, right? So once you do shape, once you check the shape of the data that you have imported in Python, you will understand if you are missing any rows or any columns, right? So there are a lot of times wherein when you export your file from any SQL database to a CSV, a lot of times one column or some rows might be missing, right? So this is a way to make sure that all the columns and all the rows are not missing, they are all there, right? Then you quickly check the data type of each column using df.info. And the reason that you do this is that there are certain times in which your data type might change. So let's say you are storing your dates in some format, and when you're ingesting in Pandas, it might ingest it as an integer, or it might ingest it as a string, right? So you have to ensure that whatever values that you're ingesting in Pandas, they are keeping the original data type, right? So strings are getting stored as strings, numbers are getting stored as numbers and not strings or something else, right? So those are the things that you have to ensure. Next thing is you have to check the uniqueness of the data, and this is something which is really important, right? There are a lot of times in which you might face an error with your analysis, or something bad might happen while you are doing that analysis. So essentially, uh, the reason at least 50 to 60% of the time I have seen is that you did not check the uniqueness of the data. You expected your data to be unique at a particular level, but there were some duplicates in the data, right? So always whenever you're importing your data, just ensure that you're checking that data is unique at the level of the primary keys. So if you are importing, let's say, students data, those students data will be unique at class id comma roll number level, right? And if you have, let's say, credit cards data, then you that particular data will be unique at customer credit card id level, right? So ensure that whenever you're importing any data, you are checking the uniqueness of the data. There are no duplicates which are present in that, right? Next thing is that you check frequency of few key columns, right? Things like months or dates or some other values that you think are really important. And the reason for this is that there are a lot of times in which, let's say, you're pulling the data from SQL, and you'll put some filters, like I want months from January to May, right? I want these specific dates, right? So all those things might break in some cases because you have written you might not have written the correct code. So it's just a good habit that you check the frequency of few key columns so that you understand that you're not missing out any particular set of data, right? Next thing is you check the null values in each of the column using df dot is na bracket dot sum. The reason for this is there are certain times in which you import the data and a particular column might not get imported properly. So it will have all the values in the CSV file, but when you're importing it in Pandas, it is giving you NAs, right? So it is not getting imported properly. So once you check null values in each of the columns, you'll understand what are the correct number of null values which should be present in the data, and then you can compare it with what you have imported, right? So let's say if you know from your experience that in case of let's say credit card data, age is missing in let's say 10% of the cases. So if you check null values in your age column in the data that you have imported, you'll be able to understand whether your age column has those many nulls or not, or is it more or is it less, right? You can also check some basic stats about each of the columns, and this is again something which you will have to develop over time, right? So the thing is that so whenever you start working in any particular organization, there are a lot of times in which uh, you will understand what are the ranges of different values, right? So let's say average transaction value on a credit card is around 1000 rupees, or let's say the number of credit cards held by a person is around on an average 2, right? So once you check these basic stats about each of these columns, you will be able to understand whether your data is correct or not, right? Whether it is representative of what you expected or not, right? Finally, a good habit is this, that you take out some random sample of the data using df.sample, and then you analyze it in Excel, right? Rather than doing everything in Pandas directly, you just analyze some sample of the data set so that if there are any issues or any problems, you are able to get that you can easily see them before starting your analysis, right? Okay, going forward, these are the different functions that we discussed last time, so I'm gonna skip this. I'm gonna straight up come to this lock and ilock and lock, right? So ilock is a way of basically subsetting the dataset or filtering particular rows or columns, right? So let's say you have this iris dataset which looks like this. um let's say if I want everything, so I'll just simply write ilock and then these two colons here. So this is basically the same way as you write range function. So if you remember range, you have to provide three different values: a, b, and c. A is where you start from, b is where you end, but b is not included, and c is the step, right? So if you don't write any of these values, you will get everything in the data set. Now let's say I want the value at index 3 for rows and index 4 for columns. So I can simply write this, and I'll get this thing. So this is index 0 for row 1, 2, and 3, right? So this is the row that I'll get, right? And if I talk about columns, it is the fourth, right? So 1, 0, 1, 2, 3, and 4. Sorry, 0, 1, 2, 3, and 4, right? So let's see what it prints. So it will print this thing, right? And if I had written 3 here, it would have printed 1.5, right? So third index and third index for rows and third index for columns, right? Or if you want multiple rows and multiple columns, you can simply write it like this. Like I want rows from 0 till 2, right? 0 till 2, because 3 is not included whenever you're writing indexes. And then again the same thing for columns. So you'll get 0, the row number 0, 1, 2, and then for columns also you'll get top 3 columns, right? The problem with this is that whenever you're working with a data set which has lot of columns and lot of rows, so generally in case of let's say banking, you will have some more than 1000 columns and more than a million rows, right? In that case, uh, it is not possible to understand where exactly a particular column is going to lie, right? But you will know that these are the different columns that I want. So let's say you would want sales column, you'll want a customer name column, ID column. So you will know the column by name, but you might not know where it is present in the data or the index of that column within the data, right? So a much better and much more advisable way of doing this same thing is that you use lock, right? When you are using lock, you don't have to do all these things. You can simply write what are the different columns that you want within a list, and what are the different conditions that you want to apply on the set of rows, right? So generally you won't have to use ilock. You'll just be using lock in most of the cases. At least 99% of the cases you will be using lock function, right? And the way it works is you write data frame dot lock, and within square brackets, right? So this is a square bracket. You specify first what are the conditions on the rows. So your condition could be, let's say I want iris ka species column which has values iris dash setosa, right? And then you specify what are the different columns that you want. So if I press this, so I'll get only these particular columns which I had listed here, right? And then condition that I had put here, which was species should be setosa. That's what, those are the rows that I'll specifically get, right? You can use multiple condition on rows. You can say iris species should be let's say setosa, and then width should be let's say greater than 3.1, right? So if you put those, then you can get that particular data set. You just make sure that you are, all the condition that you are putting on rows are enclosed between parentheses, right? And then you specify ampersand, which is for and pipe, which is for or operator, right? So your condition is my species should be setosa, and my sepal width should be greater than or equals to 3.1, right? And I want these particular columns. Okay. Okay. So I think I'm gonna skip all this thing. If you remember, then there are multiple ways of getting some specific columns, right? So you can simply write iris dot and the column name, right? I'm just putting head here so that it is not printing everything. So head will only print top 5 rows, right? So you can either write data frame variable dot the column name, right? And another way of this is you write data frame within bracket. You write the column name with this thing uh, uh, quotes, right? So this will also give you the exact same thing. So if you notice, these two things are not data frame, right? So data frame looks like this when it gets printed, right? So you have alternate rows which are white and gray, right? So this is not a data frame which gets printed whenever you're using these two uh, uh, ways to print a particular column, right? So this is called this is basically a list which is getting printed. If you want a specific, if you specifically want a data frame, what you have to do is you have to enclose between two square brackets, right? So if you enclose between two square brackets, uh, you'll get it as a data frame, not as a uh, uh, array that you're getting here, right? So this is basically what you're doing here is you're writing iris one square bracket, and then within that first square bracket you're just writing the list of columns that you want. So if I want more than one column, I can write more than one column here, right? So you have iris and then brackets, first bracket, and then within that bracket you're writing the list of columns. That's how you should read it as, right? So if I want two different columns, I can simply write it like this and I'll get those two columns, right? And same thing you can do with lock, which you had seen earlier earlier also, that you write data frame dot loc, and then you don't specify any condition on rows because you want all the rows, and then you specify the columns that you want, right? That's it. uh Here, are you with me till now? Okay, so going forward we'll be starting with the main things that you can do with pandas, right? uh okay, just give me a second. Okay. Next thing is, how do you manipulate data frames within pandas using the different methods which are available with pandas, right? So first thing that you should always do is that you have, if you have a huge data set which might have columns which will have different kind of characters, some will be uppercase, some will be lowercase. It's a good habit that you convert everything to either lowercase or uppercase, right? So the way to do that is this particular line of code. And let me just show you the different columns which are present, right? So if you want to know what are the columns which are present, then you can simply write the data frame name and then columns, right? So these are the different columns which are present in your data. You have id, sepal length, width, petal length, width, and the species of the flower, right? So I want to convert all of these to uppercase. So I can simply write the same exact thing equals to the same exact thing, and then you have to write dot str. So this is important for. So if I had just written dot upper, so upper won't work on a list, right? So upper is a function which works on only on strings. So first thing that you have to do is you have to convert this all uh, these things to individual strings, right? So for the way to do that is dot str. Don't worry about it. Just simply copy paste this particular line of code. It should be good enough, right? So I have converted everything to uppercase, right? So the benefit of this will be that if let's say there are certain columns which were a combination of lowercase and uppercases, I won't have to worry about those later on in the code. So I can simply write all the columns as their uppercase, and I'll get the correct value, right? So this basically saves you time to debug the code why your particular column is not coming in the data, but you know it's there in the data. Okay, so that was one way of so that was a way in which you can uh, convert your cases of the column names to upper or lower cases. Then you can also rename the columns, right? So you can, the way to do that is you write iris or whatever the data frame name is and dot rename. Within dot rename you have to specify one dictionary, right? So dictionary will be what is the current name as keys and what is the new name as value. So Peter length cm, I want to convert to Peter length cm underscore new. For width, I also want to convert it to underscore new, right? So within the dictionary, you specify what are the different columns that you want to rename. With the keys will be the column that you want to rename, and value will be the new name for that column, right? And then you have to specify a small thing called axis equals to columns. So this is basically uh, telling pandas that I want to rename the column. So pandas also names the rows for the data. So these are the rows for the these are the names for the rows of the data. So zero is the first name, one is the second name for the second row, right? So on and so forth. Similarly, you have column names which are actually strings, but in case of rows also you have these numbers which serve as the name of the row, right? So you have to just specify that whatever rename thing I'm doing it along the columns, not along the rows. So this is really important that you have to provide this, right? So if I run this, if you will notice that petal length cm has been renamed to underscore new. Same thing for petal width also, right? Now let's just quickly see what how is the original data set looking like. Now if you'll notice here, we did rename it here, right? We did rename these two columns here, but when I ran iris.head again, it is not showing that these two columns have been renamed, right? And the reason for that is most of the functions which are present in pandas, they will not make changes to the original data set, right? So this was a change that you did to iris, right? So it will, so while running this particular piece of code, it will not change the original data set. It will just uh, print the output, right? So output was that this dataset had these two columns which were renamed, but the original dataset has not been made any change. So there is no change which has been made in the original dataset, right? Okay, so that's what. So the way you enforce these changes is that you simply write iris equals to whatever command that you want to run, right? So if you want to rename particular columns, you simply write iris equals to iris dot rename, and then you write whatever columns you want to rename, right? If you do this and then check, then obviously even the original this thing columns in the data will be changed, right? So this is how you enforce changes whenever you are uh, running any method on in pandas, right? If you remember this in list also, right? So we had, let's say, a equals to 1 comma 2 comma 5 comma 4, right? If I write a dot sort, why didn't it sort? Oh, sorry. So it is not giving me any output, but it is still I think this is a wrong example I'm taking. I think I'm forgetting the example. But anyway, the point that I wanted to make is that there are certain functions within pandas that mostly all the functions within pandas, they won't make any change to the original data set. So to make change to the original data set, you have to write it like this, that df equals to whatever change that you want to make, right? So it will take this output on the right hand side and insert into the same variable, right? And there is a very less preferred way which I have never seen anyone using to enforce changes, is that you simply write comma in place equals to true. So what in place equals to true will do is that even without writing it like this, iris equals to iris dot rename, you can rename with just one single line of code like this, right? But this is generally not preferred. It is much better way to write something like this, iris equals to iris dot rename, right? So this is just one way that I wanted you to know about, but generally don't prefer it, prefer this kind of code, right? Making sense? I think I've been talking since a long time. I should just check on you guys. Are we good? Okay, if there are any questions, just keep writing them on the right side. Whenever I check this window, I'll answer those questions. Okay, so a less preferred way is this thing. You can simply write rename the exact same thing. It's just that you specify one more option like this, right? If you do this, so right now what I have done is I have also renamed sepal length and sepal width column, right? So everything in the iris dataset is underscore new now, right? Let's just revert back to the original names. So this is another way of renaming the columns. You simply write iris dot columns and whatever the column names that you want to provide, right? So I have just taken the original names from the original data set, right? But this way again is not preferred, because let's say you have thousands of columns, right? So you cannot write all those thousands of columns and just say that this second column I want to rename, right? So a much better way is that you use the rename function. But in case you have very small number of columns, some 4 or 5 columns, then you can use something like this also. You write just data frame dot columns and whatever column names that you want to have, then you can write as a list on the right side. Okay. Okay, then there is next thing which is called value counts. You should always use drop na equals to false within value counts, right? So if I write just value counts, it will give me the count of values for different values in peter length and peter length cm. So peter length cm has these values 1.4, 1.5, 5.1, 4.5, and all those. And this is just the count of values. So total, I have 150 rows. Out of those, 14 rows have 1.5 value, 12 rows have 1.4 value in this particular column, right? So you can sort this output also. You can either sort it by this particular column or you can sort it by this particular column, right? So if I want to sort by index, which is this thing, I just write sort index, right? And then you specify ascending false or ascending true, right? So it is now sorted by this particular column. So you have 6.9, 6.7, 6.6. So it will just go in the descending order, right? It started with 7, around 7, and it's going to 1, right? And corresponding to each of these values, you have the frequency. So 6.9 occurs once, 6.7 occurs twice, and so on and so forth, right? If you want to sort this particular output by this column, then you can write sort underscore values. So you write iris dot column name dot value counts, and then within value count just specify drop na. The reason for specifying drop na is by default value counts will not give you the count of null values. So if you say drop na equals to false, then even the null values will get counted, right? So you are basically chaining different operations. First you are just getting one column. So iris dot petal length cm will give you one column. Within that column you are chaining this value count thing, so it will give you the value count of each of the values. And then you're chaining sort underscore values, which will sort the output, right? So you can chain multiple options, multiple functions in pandas, and this is the output. So if you notice, each of these values are sorted by the frequency. So 1.5 occurred the most number of times, which is 14. That's why 14 this particular row is at the top. And then you have 1.0, which occurs only once. That's why it is at the bottom, right? Uh, you can also sort the entire data set. Again, you have to whenever you're sorting, if you want to save the data set, you have to save it in the same variable again, right? If you had just written this particular thing which I have highlighted here, then it will just give you the output which will be sorted, but it will not make changes to the original data set, right? So if you want to make changes to the original data set, you have to restore in the same particular variable. So yeah, so coming back to sort, you can sort a data set by using dot sort values function, in which you have to specify what is the column through which you want to sort on, and in what order do you want to sort. So I want to sort on column id, and I want to sort in descending order, right? Let's just see how it looks like, right? So it has been sorted in descending order by id. So starts with the highest id and then goes to the lowest id. Okay. You can sort by multiple columns, and the way to do that is just simply write all the columns that you want to sort on, and then within ascending you specify the sorting order also. So petal length cm, this thing will get sorted in descending order. Petal width cm will get sorted in ascending order. So let's just see the output of this, right? uh, so if you notice here, petal length cm has been sorted in the descending order. You have 6.9, then 6.7, and then it just reduces over the rows, right? But and then there is second order of sorting, which is petal with cm. So this will kick in only when two consecutive rows have the same value. So if you notice here, 6.7 occurs in two different rows, right? So whenever 6.7 occurs in two different rows, then you will be sorting on petal width in the increasing order. So you'll have first 2.0 here, and then you'll have 2.2, right? So petal length cm is sorted in descending order. It is the values are reducing over the rows, and petal with cm is sorted within each value of petal length cm in the ascending order, right? I hope this makes sense. Okay, so basically you just specify all the different columns in which you want on which you want to sort on, and then here you specify what kind of order you want. False means descending, true means ascending, right? Okay, moving on, you can add static columns. You can simply write iris, and then within brackets and quotes you write the new column name that you want to give. So I'm adding one more column to this particular data set with value 1 everywhere, right? And then you can also create columns using the other columns which are already present in the data. So I can create a new column called sepal length underscore square, which is just the square of the sepal length column. So I'm just gonna multiply this sepal length column twice, right? So this will give me square of this column. I can write let's say length ka average. In that case, sepal length plus petal length by 2 is the length average. Same thing for width also I can do, right? So I'm using the existing columns within the data and creating these new columns, right? So this kind of things you can do in pandas, right? So I have created this dummy column here. I have a sepal length ka square, which, so let's say if I talk about 2.6 to sorry 7.7, 7.7 ka square will be 59.29, right? Then you have length average, which is basically average of these two columns, sepal length and petal length, right? Okay. You can also create columns basis certain conditions. So let's say I have these species here. For let's say virginica I want 2, for setosa I want 1, and everything else I want 3. So everything else will be, I think, versicolor, if I'm not wrong. So versicolor is the third species of flower which is present in this data. So the way to do that is you first write that I want a static value of 3 everywhere, right? Then you specify different condition, that, and using lock again, right? So again, what you'll do is you'll write dot lock, and then you specify condition saying that wherever iris dot species is equals to iris dot setosa, right, then set this column to 1, right? In the next line you're saying the same thing, wherever iris dot species equals to, again, this is a comparable this is the comparison that we are doing. So wherever this species column has a value virginica, in that case you are storing this value 2 in the new column, right? Let's just see how it looks like. So if you'll notice here, iris virginica has a value of 2 everywhere. I'm not seeing the entire data set, that's why you're not able to see against this. But a way of doing that is you use a crosstab, right? So crosstab you can do between two particular columns. So iris dot species is the one column which was already present in the data. Iris dot new is the column that you have just created. So if I do a crosstab of this, I can see that iris setosa, wherever iris setosa is present, you have a value of 1. Wherever iris versicolor is present, you have a value of 3, right? So only this has value more than 0, rest everything is 0. Wherever iris virginica is there, you have a value 2. You have value 2, right? So this is kind of a cross tab. So how many values have 1 and iris setosa? How many values have 2 and iris setosa? So on and so forth for all these metrics, right? Is it making sense, guys? I'm just gonna check on you guys. Okay, just keep like saying few things in the chat so that I know that the connection is working. Okay, moving on. If you notice this thing, right? So this, while it does look like a data frame, it has a weird thing here wherein you have columns very far away from this particular line, right? So the thing is, this is not actually a data frame. It is actually a kind of a list of lists, right? To convert this to a data frame, you can use a function called reset underscore index, and this is something which you'll be using almost everywhere, right? So in the next set of uh, things that we will do, mostly with group by and merging and all, you will always end up using reset underscore index. So just make it a habit that whenever you are using group by and all these kind of things, you just reset index everywhere, so that the output that you are getting gets converted into a data frame, right? So if I do this, so it's the same thing that I have done here, right? Pd dot crosstab between two different columns, and I'm just simply writing dot reset underscore index here. So let's see how the output looks like, right? So now it has been converted into a data frame. You have these columns, right? And then you have the values in each of the row, right? So reset or index, just make it a habit that you're doing every time you're running any function in pandas. Okay, now how do you drop the column? So we have just added few columns. So if I want to drop a column, I have a function called drop, right? So the way it works is you simply specify what are the different columns that you want to drop, right? So you specify within a list that these are the different columns that I want to drop. And again, you have to say that I want to drop along the columns, not the rows. So I told you that pandas has names for rows and for columns also. So you have to be explicit and tell pandas that I want to drop the values along the columns, not the rows. Okay, so if I do this, you won't see dummy and new column here, right? There is no dummy and new column. Okay, so don't worry. I think there will be a lot of information overload here. So the way I would say you should do it is that I'll share this file with you. You rerun this entire code and understand each of what each line of code is doing, and then maybe tomorrow we can have a small session wherein I can give you one data set today, and you can perform your own operations on that data set, right? So kind of a small assignment. Let's say 10-15 questions along these lines only, right? Okay, you can also stack two different data frames. So you can stack side by side, or you can stack one on top of another. So I've just created two data frames here. I'll just show you how they look like. So first one has columns A, B, and these are the values in each of the rows. Second one also has columns A and B, and these are the values that are present in the column, right? So if I want to append one on top of another, I can just write df dot append, and then within bracket I can specify what are the different things that I want to append. So I want to append df2, and let's say if I had df3 also, then I could have written df2, df3, df4, df5, like that, right? Ignore index is basically, so if I'll show you how, if I don't write it, what happens, right? So what happens is the row names which were present here, right, they get preserved. So in the first df1 I had row name 0 1, and in df2 also I had row name 0 and 1, right? So those will get preserved. If you don't want to preserve these row names, because obviously you won't want a condition in which two different rows have the same name, right? So that's why you have to specify this particular column. What it will do is it will give new names to each of the rows. So you'll have 0 1 2 and 3, right? So now each of these rows has a different row name. Okay, you can stack side by side also using pd.concat. So the way it works is you just write pd.concat, and then you specify what are the two data sets which you want to stack side by side. So first one was df1, and in df2 I'm just renaming the columns, right? Because both of these data sets had the same column names, so I'm just renaming the column names in df2, right?
So if I run this, and again you have to specify that I want to stack side by side by specifying axis equals to columns. You'll get an output like this. But this is something which you won't have to use in most cases. Just in very few cases you'll have to use it. So this is just for this is just basically good to have, good to understand, good to know. Okay. Now coming to SQL in Pandas. So not exactly SQL. It's basically SQL joins in Pandas. Yeah, I had written it correctly. I just didn't read it rightly. Okay, so you can do multiple SQL joins in Pandas, like you have inner join, left join in SQL, right? So same thing you can do within Pandas itself. So if you have two different data frames, you can join them using inner join or left join or whatever, full outer join or whatever you guys want, right? So I've given you two examples of inner join and left join. Uh, okay, so let me just show you. So I'm just gonna create one more data frame wherein I'll say what is the flower name and what is the short form of it. So Iris virginica ka short form will be IV. Iris setosa short form will be IS. Right. So I'm just gonna create this data frame. Now I'll try to merge this data frame with my original data Iris data frame. Right. So I'll simply say I'll create a new variable and I'll say Iris dot merge. So merge is the function which will help you do inner join with some other data frame, right? And here you have to specify four different options. The first option is that what is the right uh, data frame, right? So left data frame is your Iris, obviously, which you have specified here. On top of it, you're merging this particular data frame. So what is the right data frame you have to specify here? So new is the data frame that I want to merge. Then you have to specify how do you want to merge. So I want to merge using inner join, right? So you specify that option, and then what are the different columns on which you want to merge on. So left side may you have species, and right side may you have flowers. So you're merging this particular flowers column with the species columns of Iris, right? Let's see how the output looks like, right? And notice here you have three different flowers in Iris, right? So if I show you here, I can get the unique values in species like this: Iris dot species dot unique, right? So you have three different flowers: Iris virginica, versicolor, and setosa. But in this particular data frame, you just have two flowers which are there. One versicolor Iris is absent in that, right? So whenever you're doing an inner join, the rows which have Iris versicolor will not be the part of the output of this, right? That's how inner join works. So I think a lot of you don't know. I mean, maybe not a lot of you, but there are a lot of still there are a lot of people who feel that they don't know SQL in the survey that I floated today. So I'm assuming that few of you do not know. So inner join is something which happens when you have the exact same values in the in both the data sets that you are merging, right? And if there are uncommon values, so in this case, let's say versicolor was not present in the second data set, so all those rows will not be present in the final output. Okay, I think this will get more clear when if we take sessions on SQL. uh, I Okay, so if I show you the output of this, so you had 150 rows in the Iris dataset, and if I get the shape now, it will just have 100 rows, right? So all the rows which corresponded to Iris versicolor have been deleted because it was an inner join. So in inner join, you will have to join only when the values are present in the both datasets, right? And if I do value counts of this particular column, you'll see IS has 50, IV has 50, right? Now let's see if I want to left join. So left join, in case of left join, you will take everything from the left table, which is Iris, and only those rows in the right table which are present in the right table, right? uh, if I do this, so again I'm specifying this, the new is my right table, I'm specifying it's a left join, and then left table will be joined on species column, right table will be joined on flower column, right? So if I press Control Enter, it will give me that output, right? So short form and flowers have been appended to this particular data set, right? Now if I check the shape now, because it was a left join, there won't be any change in the data set, right? Only when the information was present in the right table, that will get appended. There won't be any change because it was there won't be any change in the original data set because it was a left join, right? So you have null values appearing for Iris versicolor, but there is no drop in the rows. Is this making sense or should I repeat it? I'll explain Crosstab again. Okay, let me explain Crosstab again. Where was it? So Crosstab is basically you just see uh, two different columns, right? You specify two different columns, and it will create a crosstab of it. So when I say crosstab, you'll have along the columns what are the different values in this particular column, and along the rows you will have what are the values present in this particular column. So along the rows you have species, and along the columns you have the new uh, column values, right? And the values will be how many frequent, so values will be the frequency of each of these combinations. So setosa plus 1 occurs in 50 rows, versicolor plus 3 occurs in 50 rows, right? Same for virginica and 2, right? There are no rows in the data wherein iris setosa is present, and also new value is 2, right? Is it making sense, Nishit? So it's basically a frequency table, just that you have two different dimensions to it. So you do value count when you are doing value counts, you are seeing the value counts only on one column. But when you're doing crosstab, you are seeing the same value count but across two different columns. So basically the combinations of values within those two columns. Okay. And you have asked new has values of index as in row index, and the actual new values are populated as column in the right of. I am not sure what exactly you are asking. Let me just quickly check. Mm, 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 mm. Yeah. Can you repeat your question? And I think I'm not able to understand. Just repeat your question. Meanwhile, I'll answer Deba Ditta. So Deba, the thing is, if you know SQL, right? So I'll tell you how joins work in SQL. Let me just take a shot at it. Okay. Mm, Okay, so this is how SQL joins work. So forget about everything else. Just focus on these two, this top left and the middle one. Right. Rest of the joins are all derivatives of this. So don't worry about those. Mostly you'll be using either left join or you'll be using inner join. Right. So the way inner join works is, let's say you have a data frame A and B, right? And then you will be joining on some column, right? You'll say that let's say A. I'll take flowers column from A, dataset A, and then let's say what did I take here? Let's say I'll take flowers from data frame B and species from data frame A, right? So only when a particular value is present in both the datasets, those rows will be taken. And if there are any rows wherein, let's say, one flower is not present in dataset A, right? So those rows won't be taken. So the inner join works whenever you have the same value present in both of the rows, in both the data frames, right? And the left join is basically you take the entire data from data frame A and try to find as much information in data frame B which is available, right? So let's say you had three species of flowers in data frame A, right? In data frame B, you just had two species. So if you had two species, then you'll just take the information for those two species. For the remaining, you will just fill null, right? But in case of inner join, instead of filling null, all those rows get deleted completely. That's what the difference between inner join and left join is. Is it a bit clear? I think it will get more clear when we have session on SQL. I had just taken a rough shot at it. Deba, if you want to learn more, I think you can just Google or not Google. Basically, you can check on YouTube what is the difference between left join and inner join. I think there'll be some really great videos that you can find. And it's saying when you did crosstab and created a new column has. Oh, okay, that thing. Yeah, yeah. And don't worry about it. I think I'll tell you what it is. So she's asking about. Mm, mm, mm. Okay, yeah. So this was the original that you got here, and then I'm not sure how it is giving new. Okay. And just ignore this. Even I am not really sure why it is giving an output like this. But the main thing, main reason to show you this thing was that you generally get output as a what is it called? It's called a series basically, or arrays. So to convert that to a data frame, just always use reset underscore index, right? Maybe this was not the right example. There will be more better examples which can come down the line. So then you'll be able to understand how reset index works and why it is always used. But maybe this was a wrong example, so I'm just gonna remove this. Should I remove it? Okay, I'll just make that change later on. But the point here that I was making was that a lot of times you'll get outputs which might not be a proper data frame. So to convert it to a proper data frame, you just have to use reset underscore index, right? Don't worry about why you got that particular column there, because even I'm not really sure. Okay, Deva, you understood? Okay, cool. Let's just continue then. I think we should be able to finish in next 15 minutes. uh okay, yeah, so again you'll notice that since it was a left join, you'll have all the rows that were present in iris dataset. So 150 rows were present in iris dataset. Even in temp2 you have 150 rows, right? So none of the rows which were present in iris have been deleted because it was a left join. Okay, now coming to statistics in data frames. So there are a lot of things that you can do with pandas. So first and the most basic thing is you can check sum of all the columns. Let's say sum, you can check mean of different integer values. You can also do count. Let's say maybe it will work, right? So it will tell you the count of each row. So if there are any null values in any of the columns, those won't be counted. All the non-null values will be counted here, right? You can do count. You can also check n unique. So how many unique values are there, right? So id has 150 unique values, right? So if you remember, id is a primary key for this data, right? So since it is a primary key, it will always have unique value. So there are 150 rows because and then you have 150 ids also, right? sepal length has 35 unique values. Sepal width has 23 unique values, right? So I'm just gonna add a comment. Some other functions like n unique sd, etc. I think I have written it above actually. I'll just add n unique here because it's really important. Cool, right? So if you write just data frame name and some kind of function which pandas supports, then you can get that function applied on each of the columns. So you got sum here, you got number of unique values in this case here, right? You can get quantiles. So you can get what is the first percentile, second percentile, 100th percentile. So right now I'm just trying to print what is the 0th percentile, which is the minimum value. What is the first percentile, and I can also get 50th percentile. Do you guys know what is one another name for 50th percentile? Can someone answer? So 50th percentile means that you have 50% of the values below that particular value. No, and you are missing the mark. It's not mean. So it's the middle value in the data. What is another name for the middle value in the data? Yeah, it's median. So basically, you have 50th percentile, which is the median. So 50% of 50% of the values will be less than this particular value, and 50% of the values will be more than this particular value, right? And then you have 99th percentile, and then 1.0, which is the maximum, right? So you got something like this. Within iris, within id column, you have the minimum value 1 and maximum value 150, and the middle value obviously 75.50, which is the middle point of 1 and 150. But that is not important because it doesn't matter what is the median of the id column. What matters more is these values, right? So steeple length has a minimum value 4.3 and the maximum value which is 7.9, right? And median is around 5.8, right? And so on and so forth. You can see other statistics also. Now these will be really important when you are let's say doing some kind of data analysis and trying to answer some kind of question, and it's also important whenever you're, let's say, creating a model in let's say linear model, logistic model, or whatever kind of model, right? You can find correlation with a simple function called dot curr, right? So what it will do is it will create a cross tab again. So crosstab may you'll have one column, uh, one column's correlation with the other columns, right? So each column with itself will have a correlation of one. So okay, for those who don't know what correlation is, it's a quantity which tells you how two columns or two arrays are related linearly, right? So if let's say you have two arrays A and B, or two columns A and B, and as you increase column B, the values in column A also increases, right? So in that case this correlation will be 1. And on the other side of the spectrum, let's say you have a column A, column B, and you increase the values in column A and the values in column B decreases, right? So when you are increasing the value in column A and the column B's values are decreasing, then the correlation is -1, right? And let's say the middle of the spectrum, which is basically you are increasing the values in column A, but there is no change in the value of column B, that case your correlation will be 0. So essentially column B is not correlated with column A at all. And whenever you talk about correlation, just make sure, just understand you're talking about linear relation, not any other kind of relation. So this is one of the questions which gets asked in the interviews also, right? Okay. Uh, so yeah, so positive correlation means one value will increase whenever other value increases, and negative correlation will mean that it's the other way around, right? Okay. So I'll just skip this talking more about this because a lot of you might not know the significance of correlation. Okay. Now coming to missing value treatment. So if you remember when we did that session on the Titanic dataset, we saw that there are a lot of cases in which the values might be missing in the data. So what do you do then, right? So let's just say I create a data frame here. In this case, I have lot of missing values in lot of the columns. So column A has 3 missing values, column C has all the values which are missing, right? So now what do you do with them? So one thing is that if let's say you know a particular value that you want to fill there, so in most cases it will be 0. So let's say if sale, you have a sales data set and the sale column is null, in that case the sale value most probably will be 0, right? So you just simply put 0 there. You can simply use 0 whenever any value is missing, right? So to do that for the entire data set is something like this. You write df dot fill na and 0, right? So this will fill up the entire data set wherever there is any null value with 0, right? A better way to do is that you identify what is the value that you want to fill for each of the columns. So let's say in A I would want to fill 3, right? So I'll say df dot a fill na equals to 3.0, right? So it will just fill that particular value, right? So all the values which are missing in column A have been filled with 3, right? So if I fill the entire data frame with value 0, it will look something like this. So all the missing values have been filled with 0, right? Okay. Or if you write something like drop na, it will drop all the rows which have at least one missing. So if you notice here, there is column C which has missing everywhere. So essentially the output of this will be all the rows will be dropped, right? So this is generally not preferred. There will be very rare chances in which you will do this. In most cases you'll be doing this thing only, right? So if you have missing values, you will either drop that column. Let's say in this case you'll drop column C because all the values are missing. There is no point in keeping this column, right? And in some cases you would want to fill the missing values with the mean of the column, or in some cases you want to fill with the median of the column, or whatever that you think is the best suited for your case, right? So in that case you can use this particular function called fill na, and it will help you do the job. With me till now, I think we just have 5 minutes of effort left and we should be good. Any questions so far, guys? Group by is the most important thing in Pandas, so I want to take some time, freshen up, guys, because it'll just take 5-10 minutes, but it is really important. How do we drop the column? I told you, right? So you use a function called drop. Let me see, let me see, let me see, let me see, let me see. It's here. Yeah. So you write data frame name dot drop and the columns that you want to drop within a list, and then you specify axis equals to columns. Right? What else? Any other question? And Debadita, Nishit, you asked, Anand, Saurabh, Sakshi, Shah, Shalmali. I hope I'm pronouncing your name correctly. So if you guys have any questions, just let me know. We can answer. Okay, cool. Chalo. The final thing which we should cover is group by. Okay. Where is it? It's here. Okay. So one of the most important utility of pandas is the group by function. What group by allows you to do is it allows you to aggregate on different columns, right? So let's say you have a data frame of marks obtained by each student in the class, right? So let's say you have 50 students and they have taken some 5 subjects, and each of these 5 subjects you have the marks that they have obtained, right? So there'll be cases wherein you would want to sum up the marks for each student, right? So you'll take each student, for each student you will take marks in physics, chemistry, maths, English and Hindi, and then you sum those up, right? So the same thing you can do in pandas using group by function, right? So way it works is you write the data frame name and you write dot group by, and within group by you write the different columns on which you want to group or on which you want to aggregate. So in the example that I gave you, it would be the roll number, right? For every roll number I want to group up the marks, right? So this is that thing. So right now I'm just grouping up by species, and I'm just applying a function called sum. And again you'll do the reset index thing here. So let's see, let me show you an example what happens if you don't do it, right? It comes like this is not a data frame, right? So I can convert it to a data frame like this. Now it's a data frame. You have columns, you have rows, right? So for every species I'm just summing up all the columns. So id column is summed up, sepal length is summed up, sepal width is summed up, and all the other columns are summed up. And I can also run other function, let's say mean I can do, or I can do let's say standard deviation. I hope it works like this. You can do std, right? So this will give you standard deviation also, or you can check count of values, right? So each of the columns will have 50 count for each of these species, right? So let me just revert it back to sum, right? So this is how you'll aggregate in pandas. This was the most basic example. Now let's move on to if you want to, instead of aggregating for all the columns, you want to aggregate only for few columns. In that case what you can do is you can write the same thing, iris dot group by, and within bracket and a list you specify what are the columns on which you want to aggregate on. So right now I just want to aggregate on species, so I'm writing species here, and then you write another list of the columns that you want to aggregate. So I want to aggregate length, average and width average, right? So you specify those columns and then you write mean or whatever function that you want to apply, and then again reset index is always applied, right? So what this will do is it will first group by this entire data set on species column, right? It will take out these two columns from the data, right? And then calculate the mean. Let me just show you, right? So if I show you the sum thing so that you can compare with the above example, right? So in the above example I had done it for all the rows, all the columns. Right now I'm doing only for these two columns, and if you'll notice that these two values are same exactly, 161.75, 161.75, so on and so forth, right? So this ensures that the calculation is being done only on the columns which you want in your final output,
right? Let's say, so right now we had done only one aggregation, which was just sum, mean, or unique, or whatever we did earlier. So it was just one kind of aggregation. You can also do multiple aggregation, right? You can say, and the way to do that is you write dot agg instead of writing the function here. You write dot agg, and you, within that bracket, you specify the list of functions that you want to apply, right? So this, what this will do is it will apply min to length average and width average. It will apply max to length average and width average. So it will give both kind of aggregations, right? It looks like this. Okay, you can specify more things also. Let's say you want mean also. It will give you for every value of species. It will give min, max, and mean of length average, and the same thing for width average also, right? Now, this what this will do is it will apply the same aggregation to both the columns. There will be certain cases in which, let's say, you would want, I want minimum of length average and maximum of width average. So the way to do that is you specify again the ag function, right? And you can say that for length, and then you specify a kind of dictionary inside, right? So dictionary, the values will be, the keys will be the columns, and the values will be the kind of aggregation that you want to apply. So on length average, you want to apply minimum. On width average, you want to apply maximum, right? So if I give you the output of this, you have now got minimum of length average and maximum of width average, right? So that's it. That's how group by works. So group by is really, really important. Whatever assignment I'll give you, you might have to do group by at least 50% of the time, right? So yeah, just be mindful of that. There, I think these two things I've already covered above. So you can get unique value in a particular column. So you have three different unique values in species column, right? So you write iris dot species dot unique. It will give you all the unique values. If you want the count of unique values, you can use n unique. It will give you three unique values are present in the column, right? I'm gonna skip matplotlib because I don't have really good content here, and I don't want to give mediocre content. Okay, I think we're done. You guys can ask questions, and then we can spend some 5 minutes on future steps. Okay, since none of you are asking questions, I'll show you what is the output of the survey that we did today. Um, what? You guys can ask me questions. I mean, you don't have to wait for me. Okay. So in case of responses, uh, yeah. So first choice is mostly SQL. So I think SQL is something that I would definitely want to do. And second choice, people have chosen traditional machine learning, traditional modeling like linear regression and logistic regression. Third choice, if I'm not wrong, it was machine learning or basic statistics now. Okay, cool. So these two things I'm not really sure because a lot of you uh, were not really comfortable with what we taught already. So we can take up logistic regression and linear regression and machine learning topics a bit later on. Let's say a month down the line. uh, I would say we can do some sessions on SQL first because that is a really important skill for getting jobs. And then we can do some sessions on case studies and guesstimates because a lot of people had reached out to me. So although I understand I'm not being democratic here, like a lot of people have not chosen these two topics, but personally, I feel that those are the most important topics if you are looking for the job, right? And my intent is not to teach you new topics. I really want you guys to get a job as soon as possible. Maybe if you already have a job, maybe you can apply for a new job, or if you're a fresher, then you can get your first job, right? So that's the main aim of these sessions, not
to teach you new things, because there are a lot of courses already which are going on over Udacity or Udemy, or even on YouTube. You can learn different things, right? Uh, so the sessions that I organized were specifically from the perspective of helping you to understand what exactly is asked in the interviews, how exactly you can prepare resumes, what are some tips that you can use for case studies and guesstimates. Not, we didn't cover guesstimates although. So yeah, so that was the main aim. That's how I will organize the upcoming sessions also. So SQL and sessions on case studies will be the upcoming ones. For machine learning and things like statistical learning, logistic regression, and linear regression, I would want to organize sessions, but just that I don't want to organize it for, let's say, just less than 20 people, right? So I want more people to be interested in the course, so that whatever effort I'm putting, it is helping a lot of people, not just very few people, right? And it takes a, like, you would understand that it takes a lot of time putting all these things together, right? So yeah, so that's it. Thanks for joining me for 8 sessions. I think almost all of you who are present here have been with this in start. I really hope you got something out of these sessions, and we'll continue this in future. If you have any comments, you can just write on the right side. Any suggestions, uh, any critique, or anything basically, and we can stop at 8:30. You don't have to ask me question regarding Python. You can ask me regarding other things also, interviews or whatever. I mean, it's up to you. Thanks, Nishit. Thanks, Anne. You're welcome. Oh, by the way, I posted, I think 2 to 3 weeks back, that there might be openings in my team. That's still true. The thing is that we haven't yet created job IDs for those. So once the job IDs are created, I can refer anyone who's interested in those jobs. You're welcome, Sharik. Uh, You're welcome, Saurabh. So I was thinking that I can maybe call my manager and my director to a session, and they can answer a lot of queries that you guys might have. So things like how is it looking in the analytics world? When will they start hiring? Or let's say, what are the tips you would give to a person who's choosing data science or analytics as a career? So anything that you would want to ask, we can compile a list of questions and we can ask like really senior leaders in the industry. You're welcome, Debarita. Yes, Sharik, I will arrange session on interviews. Okay, great. Cool. I'll what about the individual mentoring you talked about after assignment? Ah, I completely forgot about it. I think Devadita thing is, since just there are just 11 of you left now, so I don't think I'll put effort into creating an assignment. I'll just give you an assignment on Pandas. I don't want to spend a lot of effort in making it auto gradable. I already did that effort for the first quiz, which we discussed in the session today, and only 30 people ended up like filling that, right? So I don't want to put any more effort there, because not a lot of people are getting benefited from that. But since I promised that I will help you out individually, what I can do is, you guys can just drop me message on my WhatsApp, and let's see what I can do to help you, right? So just drop me a message, and we'll have a small call if you guys want, and we can discuss what exactly like we can help I can help with. Is that cool, Deva? You're missing few familiar places. I think Abhishek is missing. Sakshi was here. Sakshi was here. Okay. Anything else, guys? Or should we drop off?
Okay. Let's drop off then, and what? Yeah. So thanks for joining. Next steps, I'll just paste in the WhatsApp group whatever the future things we have planned. Right. Thanks, guys. Thanks for joining. Let me see how exactly I can close this.